Starbucks man, Josh Long.
All right, good stuff. Thank you. So do I just hit share screen? What do I do?
I will just. It's there.
We're good. We're live.
Yep.
Oh, I'm so excited. So thank you both of you for kicking us off. I appreciate everybody else being here. There's normally I joke that you have a lot of good places that you could be right now, and that's to some extent kind of true. But let's be honest, you're probably at home, and that's okay. It's a good cause. This is we can do this, but we don't have a lot of time. I just learned that we have about 30 minutes to cover this, so let's get going. Now, my name is Josh Long. It's very nice of you to join us all today. We're going to talk about the Reactive Revolution. There's several things that you should know. First of all, we've got a new book called Reactive Spring, about which in which I talk a lot more about the topic that we're going to cover today. The podcast I do is on bootifulpodcast.fm. You can find it on all the places where you find good podcasts. And of course, the code for the presentation is there at github.com, Josh Long, the Reactive Revolution. Now, let's talk about what we're going to be talking about here. Let's talk about why we care about reactive programming. We all want to handle more users. We all want to make better uses of our resources. And of course, that's made a bit more difficult right now because of the way that we use threads on the JVM. Threads are expensive. And unfortunately, if you log into existing systems, you'll see that the JVM is used to build services. And if you look at the use of those JVM services, you'll see that the CPU usage is actually fairly low because the services are mostly idle. All the threads are in a wait state, waiting for something to happen, but not otherwise doing anything. CPU usage is low because most of the time they're doing input and output. This is because input and output in these sorts of environments is based on synchronous and blocking Java IO input stream. When you call .read on the input stream interface, the client thread stalls. It sits there waiting for the next byte, but we don't know when the next byte will arrive. We don't know if it will arrive, and we shouldn't write code that is so dependent on the next byte being there. We shouldn't be writing code that is so prone to failure. Such code will have no way to exit, save for some exception, perhaps a timeout, and worse, it monopolizes a thread that some other thing in the system could or should be using instead. So what we need is a programming model that flips that around, that gives us the ability to say, hey, when there is data available, call me back. Give me the ability to continue processing when I can, but no sooner. And in the meantime, don't keep this thread open. Let somebody else reuse the thread while something else in the background, babysits that file descriptor waiting for that data to arrive. That's the essence, the crux of reactive programming. It gives us a programming model that lets us contend with latent, potentially unlimited, potentially faulty, and certainly asynchronous streams of data. There's a much more natural way. This is a much more natural way to sort of view the world when you think about it. As a result, all programming is the one kind of thing, right? It's all reactive. It's all these sort of asynchronous reactive data types. It becomes very easy to compose applications written in the style. So that's what we're going to talk about today, my friends. That's what we're going to look at today. And of course, in order to do that, we're going to build a new application. We're going to do that by going to my second favorite place on the internet after production. Obviously, I love production, and you should love production as well. But what we're going to do is we're going to build an application on my second favorite place on the internet after production. So if you haven't already gotten to production, you can begin your journey here at start.spring.io. And now I'm going to make that a little bit larger. And you can see that there's a few things that have changed about start.spring.io recently. First of all, dark mode. How cool is that? I agree, it's the best. And also a new user interface. So there you go. We're going to build a new application using Maven. We're going to use 2.30 M4. We're going to use Java. I am going to use Java 11 or 14. Anything works just fine, but really you should be using Java 11 or later, ideally Java 14. And we're going to build a new service. And the service is going to be called Service. And we're going to bring in certain dependencies that we need to be able to get the job done. So we're going to bring in the reactive web support. We're going to bring in the reactive MongoDB support. MongoDB, okay. We're going to bring in PostgreSQL. We're going to bring in the reactive. We've got that. We got one RSocket as well. So we got reactive web. We've got reactive MongoDB. We've got PostgreSQL. We've got RSocket. I think that's enough. I think that's pretty much everything I want in order to be able to build this application. So again, pretty lightweight stuff, but notice that we have to choose the reactive variant of these various dependencies in order to get the job done. So let's hit generate. That'll give us a new zip file. I'm going to close Slack because goodness knows I don't want to, sand pit in the middle of a presentation just staring at Slack and going, what's going on? Why do people say the things that they say? So here we go, UAO service.zip. Opening this up in my freshly installed 2020.1 installation of IntelliJ. So pretty, so nice. Here we go. Don't show me this again. I've clicked this every time I've restarted IntelliJ. I've said, don't show me it again, and it shows it to me every time. So I get the feeling there's a disconnect between my definition of don't show it again and its definition. So here we go. We got a new application. I'm hoping you can see that. Let me make the font just a little larger here, friends. Font. And that's 22. That'll be hopefully large enough. So we're gonna build an application that saves data to the database. We've got a couple databases here that are usable. So I've got MongoDB running on my local machine in the background, and I've got PostgreSQL. So for now, we're not gonna use PostgreSQL. So let's comment out the, oh, I don't have the RSocket bits here, do I? I could have sworn I chose them. Oh, that's my problem. So look at that, R2DBC. See, I can retroactively add to it and just go explore and then just copy and paste the bits that I neglected to grab the first time around. So here we go, Reactive MongoDB, everything in between the dependencies. I just like to actually just copy and paste it all, I guess, right? So here we go, copy, paste. Good, fixed it. So now I'm gonna comment out the MongoDB, sorry, I'm gonna comment out the R2DBC bits here. Get rid of that, get rid of that, and we're going to get rid of that, okay? So now I have an application that's just going to talk to MongoDB by default. It'll connect to localhost. I'm going to write data to the database, and I'm going to use that Spring Data ORM that's running in the background there to do the work for me. So I'll create an object to be mapped to fields in the database, and I'll describe those fields with annotations thusly, so document and so on. This is the essence of what I want to do, but of course I need getters and setters and all that kind of stuff. So I could do all that stuff myself, or I could use Lombok, which I've also apparently neglected to add here. So let's do that. Lombok, okay, control space, explore, and just look for Lombok. There we are, okay, good stuff. Now, Lombok is a compile time annotation processor. It'll make it easier for me to generate the getters, the setters, that kind of stuff that I need to do the work. Let's see here. Maven, re-import, please. Good. There we go, at all args constructor, at no args constructor, good stuff. So there's the essence of our entity. Now we're gonna create a repository, and this repository is just gonna be an interface that we extend from the Spring Data Reactive MongoDB project, Reactive CRUD repository. Now this repository is gonna manage instances of reservation whose primary key is of type string. This is an interface that we don't have to implement ourselves. There are several different methods here whose names are fairly straightforward: save, find by ID, check if exists, count, delete, etc. What is interesting are the parameter types that are accepted. The first of which is a reactive stream type. So from org.reactivestreams.publisher, a reactive stream publisher publishes data asynchronously and out of band to a subscriber. The subscriber listens for the data, processes each new message in the onNext method or in the onError method if there are errors. When it's done processing, it calls onComplete. And when it first connects to the publisher, it is given a subscription. The subscription is very, very important. The subscription is what the subscriber uses to control the rate of production by requesting more or less of the data. This is called flow control, or alternatively, back pressure. You can also cancel the production of the data. So here, the consumer controls the rate of consumption. This creates and promotes stabler services, okay? This is very important. We also have a processor, which is a bridge, it's a source and a sink. If you understand these very, very simple 4 types, then you understand the Reactive Stream specification. That's it, that's the entire thing. They're very useful, but they're very Spartan. So what we want is 2 specializations. One that describes a single value, kind of like a completable future. That's called a mono. It's also a publisher. And another one that describes a potentially infinite stream of values called a flux. It's a publisher as well. Both these come from Project Reactor, which is a Spring team project that doesn't depend on Spring, right? Spring depends on it, but you don't need Spring to use it. This project also provides lots of operators that we can use to compose our reactive stream. So we now have the service application, we have our repository. Let's write some sample data to the database, okay? And we're gonna create a bean that listens for an event. So application ready event, okay, ready event.class public void go, right? And it's just gonna be a regular Spring component that we're gonna use. We're gonna inject a final reservation repository. Here we are. And inject that into the constructor using required args constructor, again from Lombok. Now there's my basic application, my basic object. I'm gonna create some names here and just write them to the database. So my name is Josh, it's nice to meet you. Let's go through some names on the Spring team. Madura, Cornelia, we've got Violetta, we've got Yushin, we've got That's 5. I guess we need some other Spring people. There we go. We've got, who else do we have out there in the world that is, oh, Simon, he's not here, but I haven't talked to him all day. There we go. Names, okay? So some names there. And for each name, we're going to visit that and turn it into a reservation like so. So there we go. And then for each one of those, I'm going to save it to the database. Now, I could and probably should just extract that out to a separate variable and then visit each one like this. If I say map R, and then I say reservation repository.save, what's going to happen is that it's going to return a publisher, right? So it's going to return a publisher of mono. It's a publisher of reservation. So it's an aggregate type. It's a container type. And this map method aggregates the nested method. So it'll be a publisher of reservation. I don't want 2 nested publishers. I want just one. So what I'm going to do is I'm going to unpack that intermediate type. I'm going to flatten basically the types there, similar but separate from flattening the curve, which we should all be doing, right? So there we go, flat map, save, and there's my now stream of reservations that have been saved into the database. If I run this program right now as written, nothing will happen. I need to actually subscribe, okay? Subscription actually forces these publishers to actually execute. By default, they're like pipes into which you have put data, but nothing flows, okay? So I'm gonna say map1.subscribe, and then as I do that, I can actually put a consumer in there, a Java 8 consumer, and print out the results if I want, okay? So that's a very simple thing to do. I could clean this up a little bit. I like to clean this up, tease out the variables a little bit here. Good stuff, and then subscribe, okay? So there's the whole pipeline as just one sort of thing. I actually want to save things, but I want to delete everything in the database first. I want to reset, so I'm going to do delete all, but that's an asynchronous reactive stream. So remember, that could all happen on separate threads. So I want to use operators to guarantee a deterministic ordering. I want to say delete everything, and only then, after all that's done, only then do I want you to write the data to the database, and only then, finally, do I want to find all the data, and only then, finally, do I want to subscribe and print out each of the records, okay? So good stuff. There's the entire pipeline. Now, if I run this code right now, it'll work. Let's try that out. But I'm gonna then want to create an HTTP endpoint. Okay, so one thing I could do, as per normal, as you might expect if you've ever used Spring MVC, is to create a reservation MVC or HTTP controller, right? So HTTP controller or REST controller. Actually, that's what I want here, isn't it? It's a REST controller. So it's going to be private final reservation repository. Okay, and at get mapping. I can do this just like I've done a million times before, and I'm sure you probably have as well. So here I'm just creating a HTTP endpoint that'll read the data from the repository and return it to the client. Okay, so that's a very straightforward thing to do. I should create a constructor here as well. I quite like this style. It's a Spring MVC style. It's very familiar if you've ever used it. But these days, I much prefer the new functional reactive style like this. So at bean router function server response. Okay, routes. Here we go. And I'm going to return route. Okay. Okay, dot build. And it'll be get / reservations. So I'm providing the same basic setup here. I'm providing a lambda that gets called, that gets invoked in service of the response. Okay, so the response is just going to be a reactive stream that I'm going to get from that repository, which is a collaborating object, which I'll just inject here. So RR, and I'll say rr.findAll reservation.class. Okay, so there's the reactive stream. Good stuff. There's the rewritten code. Restart that. Now, so far, if this works, you'll have seen that I've been able to write data to the database. I've got MongoDB, I've got my HTTP endpoint. You can see that that data is reflected here in the console. If I go to the browser, I can go here, localhost 8080 reservations. There's the JSON that comes back. So it's all working, but this is a NoSQL data store, right? And there are many different NoSQL data stores, with which you should become familiar if you haven't already, and there's a lot of good options there. We support reactive variants, specifically separate code bases for different technologies. So Google Cloud Firestore and Spanner, Cassandra, Cosmos DB from Microsoft Azure, Redis, Neo4j, Couchbase, Elasticsearch, etc. But people often ask, well, what about SQL? What about SQL data stores like Postgres and so on? And so in this case, we have an abstraction called R2DBC, which is the Reactive Relational Database Connectivity abstraction. And it's built on top of the Reactive Stream specification, which we've been using all this time. So I'm going to go ahead and comment out MongoDB, and I'll bring in the appropriate types here. So this is no longer a document, right? That only makes sense in the MongoDB context. And this is going to have a monotonically incrementing primary key. But otherwise, it's basically the same code as before. So let's go ahead and restart that. It is stunning to watch how slow compilation becomes once you have a screencaster on your screen when you're recording things on the machine. Oops, what did I do wrong there? Oh, I forgot to provide a URL. So application spring.r2dbc.url, r2dbc.url, r2dbc postgres. Okay, localhost orders, username, orders, password, orders. Okay, I'm gonna restart this. Come on. Some other error, is it? Can I auto-generate of, really? I feel like that should be easy. Let's get rid of this, by the way. And integer. That's confusing. Do I have that table here? PSQL, U orders, D, select all from reservation. Okay, D or reservation. It's got a primary key automatically. Okay, doesn't really matter. I'm gonna go back to MongoDB. Do not have time to figure out what happened in the latest milestone there. I'm using the milestones.
Josh, it's still using MongoDB in that error right below it.
Oh, wait, what? Why is it? Oh, it's a Maven build. Sad. Okay, thanks, buddy. Pair programming for the win. So Maven, do your thing, just this once. Okay, good. Son of a gun. Okay, compiling. Really, I already asked it to compile minutes ago, years ago. It's been compiling for this time. Okay, come on. You can do it. There we go. Thanks, buddy. Matt for the win. So there we go. So select all from reservation. We're back. It's working. Matt Cornelia, blah, blah, blah. There are our names. So now we've got data in the database. We've got a SQL data store. We've got 8 records coming from JSON. This is not new. This is not particularly useful. You could have done this yesterday with JDBC and servlets. What I showed you all this for is to make you understand that you have parity. It's just as easy to do today what you could have done yesterday in the non-reactive world. That said, your options are not limited at these very simple things. Where reactive programming really comes into its own is where you can do things that would have otherwise monopolized a thread in the old world. So imagine a chat system or a stock ticker or anything that requires liveliness that would have required a client to make a connection to a service and keep a socket open. In the old world, that would have required a thread be monopolized or dedicated to that socket. But now we can decouple that link. Keeping a socket open doesn't mean keeping a thread open. I can have thousands and thousands of file descriptors in my operating system that are open, but I cannot have thousands and thousands of threads, right? The computer doesn't like. So what we are going to do is we're going to be using the reactive support here to build a WebSocket endpoint that produces an infinite stream of greetings, okay? So greeting service, and I'm going to create 2 DTOs, so class greeting request and class greeting response, okay? Now, this is going to be a DTO, okay, nothing special about them, just 3 annotations to make them provide all the normal machinery of a Java bean, okay? So the name is gonna be the thing that we send in, and the response will be the message that we get back, okay? So 2 DTOs, one has an envelope for a name, and the other one has an infinite stream, or the other one represents the message that's gonna be sent back. We're gonna create a service, I guess we could create a service. So publisher, of greetings response, okay? Greet given a greeting request, okay? So here, I'm just gonna create an infinite stream. I'll say flux.fromStream, stream.generate new supplier, okay, new greetings response, hello, request.getName at instant.now, okay? .toString. So I'm going to create an infinite stream, but I want to actually stagger the results of that stream by 1 second. I'm going to introduce a little bit of time here. And I can do that because I have a scheduler behind the scenes. That's one of the things that moves the flow of execution from one thread to another in our application. That scheduler is what makes Reactor so darn good at Tetris packing up our different threads and making sure we get the most efficiency out of it as possible. So now I've got the scheduler, and you don't have to worry about that scheduler, by the way. By default, you have 1 thread per core. And you can override the scheduler if you want to. You can actually provide a custom one here, for example, but you don't need to do that. If you ever find that you are starved for threads, that means you're doing something that's blocking the threads, which you shouldn't do. And if you want to find out where you're doing that, we have a nice Java agent you can use called block count. Here's block count. It's a Java agent that we built for you. It detects silly blocking interactions on the thread, which you should never do anyway. So now I've got our service, our infinite greeting service. I want to export that and then consume it. So what I'm going to do is I'm going to make this an RSocket service. I could use WebSockets. I could even try service and events, but for service interactions, I'm going to use RSocket. RSocket's a very nice fit for high-speed services. So what I've done is I've added Spring Boot Starter's RSocket to the class path. RSocket, you have to understand, is a protocol that was designed by engineers who came from Netflix, who work at Facebook, and it's a very simple binary protocol that does not care about, it doesn't have any limitations. So it doesn't care what protocol you use or what payload you use. It's not like gRPC where you have to have Google protocol buffs. It does completely bi-directional communication. So it's not like HTTP where you're limited to request response. It's it's just generally a very, very flexible protocol. And we support it out of the box. And that's because, in part, the Java client that Facebook built to support this natively reactive wire protocol is built on Reactor. So it's trivial for us to then provide a programming model, as I just demonstrated here, around RSocket. So now I've got this RSocket service. 7070. I've got this RSocket service up and running, and I've got my regular HTTP service. Let's go ahead and build a client to consume all that, okay? We'll go back to the initializer here, okay? And we're going to rebuild. We're going to build a new thing here called a client. Okay, and we're going to add a few different dependencies that we want. So we want the reactive web support. We want the resilience for JBits. We want that. We want the Lumbuck. We want RSocket, certainly. Okay, so we got reactive web, resilience for J, Lumbuck, and RSocket. Seems good enough for me. We got 2.30 M4. The only mistake I made was I didn't choose Javelin. That's an easy enough fix. All we got to do is actually, I think I'll just delete it and try again because I don't want to have to do the Maven dance once we get up and running. So here we go. Java 11, just for the win. Explore. Generate. Good. Now, here's my client. We're going to open that up in the IDE as well. And this is going to be any old client that would talk to any old service. And this is really the wheelhouse for reactive programming. Okay, I'm going to tell IntelliJ to not show this again. Could have sworn I just did that. Isn't that funny? Deja vu. So I'm going to hit client application, and this application is going to be a thing that consumes the other service. And there's a lot of patterns here, right? So I'm going to start up the application on a random port. So it'll be a 9090. Okay, that'll be the HTTP endpoint. Actually, you know what? Better yet, we can tell it not to create a web application at all. So application type, web application type equals none. Okay, so I have a reactive application. And we've got WebFlex, we've got RSocket. I don't know if we're going to need this, but it's just nice to have it on the class path just in case. That's a circuit breaker. Okay, so now what we want to do is we want to call that downstream service. And there's a few different ways to do this. One is we create a HTTP call, right? A reactive web client call. So this would be our HTTP client. In order to build this, we just return a web client. We just inject the web client builder, like so. And we say builder.build, good. Or in order to talk to our RSocket code, we need to have an RSocket requester. Okay, so we say RSocket to me, baby. Okay, and builder and return builder dot. And here the protocol is actually stateful. So a lot of times when you use HTTP, the protocol disconnects on each call. But here, RSocket maintains a connection through the life of the application. Of course, you might have to reconnect and all that stuff, and that's doable. But basically, you connect once, and then you can make calls much more efficiently than you would if you were not using something like RSocket. So now I've got an HTTP client and an HTTP service. Let's build an HTTP client that uses that. So I'm going to build a thing that injects the HTTP client. So HTTP client, web client, here we go. And it'll be a bean that'll just be invoked when the application starts up. It's an application runner. And here, all I'm going to do is I'm going to write code that makes that network call using HTTP. So I can do this very easily. I can say http.get.uri http localhost 8080/reservations, and the data that comes back, I'm going to retrieve it and turn it into the Java reservation DTO. So I've got that on the server side. I'm going to do something terrible here. Again, something you should never ever do. I'm going to copy and paste code. So here we go. There's this, and I'm going to take my reservation as well. Paste that here, and get rid of the ID. Goodness. So now we've got our reservation DTO. We can now bind the resulting JSON from that HTTP endpoint to a reservation object. And I'm going to I'm just going to stream through all the reservations. So I can say reservation.flux or subscribe, and I want to just subscribe and print out the results. I'll use a logger here. I'll inject that through Lombok, and I'll say log info. Okay, now as I make this network call, keep in mind what's happening here. I'm making a network call to the service, even ignoring the hard-coded username and host and port here, which is almost as bad. Even ignoring the hard-coded host and port here, I should be using something like a client-side load balancer so that I can look up service instances through the service registry, or I should, in the worst case at least, use DNS. But for now, I've got a hard-coded host and port. Even ignoring that, assuming I was doing something correct, can I assume that that service is always going to be available, that it'll always produce a response? Well, certainly not, right? So I want to take advantage of some of the inbuilt operators that we have here to make our code a little bit more robust. So if there's an error, okay, I want to default to a value. So I can say, okay, on error resume, provide a fallback. And actually what I want to do is I want to get the names. So I'm going to map each reservation to its name. That's I'm doing some sort of very trivial mapping over the results there. Okay, so now I'm going to say for each one that comes back, if it doesn't produce a response, if there's an exception, just return eek. Okay, now what about
this is your 2-minute warning.
What is it? 20
2-minute
minute
warning. Yep.
2 minute. Oh, okay. Well, if I want to get a retry, I can retry there if I want. I can also do what else can I do? I can do timeouts as well. So there's a lot of options that are built in there. So duration dot of seconds, etc. Right? I can time out 1 second. So a lot of options there. I encourage you to look at that. What about our RSocket client? Okay, RSocket requester, our client, RSocket client application runner, RSocket client, and here I'm going to use the RSocket requester that we just built. Return args. Okay, and I'll say RSocket requester dots. Route. The route is the greetings endpoint there. The data that I'm going to send in is a new greetings request. Okay. All the talks. And the data that I'm going to get back is a greetings response. I'm just going to visit each one of those as well. So I'll say subscribe log info. So now let's just format the code and run the application. Fingers and eyes crossed. You can see that it's very easy to make these network calls, assuming I typed everything correctly, which statistically not likely. Okay, so this service didn't produce the right HTTP response, but the greetings response started to produce the responses, but then of course the HTTP server shut down. I should have done something to keep the thread alive, like system.in.read, but either way, you can see what I'm trying to show you. So my friends, reactive programming gives you a way to do not just what you could do before and with more ease, because now everything is the same kind of data type. It's all publishers all the way down, but it also gives you the ability to do more interesting things like really, really easy composition. There you go. I just did it with the system.in, and you can see it was able to get the HTTP response and the never-ending reactive stream of RSocket requests and responses. I want to thank all of you for joining me today. I want you to stay home, stay safe, flatten the curve. Thank you so much for your time. Thank you, all the talks, for having me. I appreciate it.
Thanks, Josh.
Thanks, buddy.
All right.